Good. So, hello everyone, and thank you for connecting with us today. I am Shalendra Dubey. I'm leading the sales for business line matters for ABB for South Asia, Middle East, and Africa region. Our topic for today's webinar is connected steel, a deep dive into digitalization strategy. So, before we deep dive into this strategy, let me also introduce our esteemed speakers here with who are there with me today on this panel. Tarun Mathur, who is a global sales manager for digitalization portfolio. He has been with ABB since 2006, and he has held various positions, including in research and development. He has been driving the advanced process-based model, and in present role he is focusing most on optimizing digital technologies, pushing the solutions to steel industries. So welcome, Tarun. And then we have a very important guest who is coming from the end user industry itself, Mr. Gaurav Patil. Gaurav Patil has been instrumental in driving innovation by utilizing digitalization within the steel process, including logistics. He will take us through some of the digitalization project that he has implemented within the steel industry, within the JSW group, and what are the key learnings from those projects. So welcome, Gaurav. Uh, before I hand over session to our speakers, just a few minutes from my end, what we really want to achieve together with this webinar session. Of course, the idea is not to, load you all with tons of digitalization products and solutions. We would love to have a very engaging session, and we would love to have more questions coming from you. You can type your question in the chat box that you can find in the bottom right corner of your window. We all know that steel industry has a very critical role to play, when the world is really uh, fighting this uh, increase in the weather challenges that we are seeing today. And also, steel is a very essential commodity for our economy. So it's one of, how to really balance this challenge, being as one of the being most largest consumer of electrical energy or energy, as well as one of the largest emitter for the greenhouse gases. So there is a lot of technology development is going on. How we can achieve the decarbonization in the steel industry. I think this is one of the major challenges that we see today. It needs a lot of financial commitments from the customers, and I think it's not easy as well, when we are going through this path. So one of the critical aspect of this is also to start with the sustainability, and then with the sustainability we move towards the path of decarbonization. So once we have sustainability in place, when we have sustainability products and solutions, and then with these savings, we increase our profitability, and this with profitability, we move further into investing into the decarbonization process. But where we as a digitalization come into picture, in between sustainability and decarbonization, with using all the digitalization tool today, which is powered by AI and machine language, I think we can transform this process of sustainability, when we are moving towards towards the decarbonization, and we can achieve optimization in our process that we are seeing in the steel industry today. ABB, being a leading supplier for electrical and automation, uh, is like core to this transformation journey. We have developed these solutions and products which can really help to achieve this transformation. And I think Tarun will further take us through all these solutions and products that we have been developing, we have been uh, implementing at various locations in the steel industries. But this is a process. I mean, we all need to understand that, they are enormous. I would say that capabilities are there with this digitalization tool, but we need to start somewhere. So, and we need to take initiative. So we will have Tarun who will be taking us through the solutions and product and how we have been improving the sustainability of the steel industry. So over to you, Tarun. Thank you.
Thank you, Sharendra. Thank you. Can you hear me loud and clear?
Yes.
Okay, great, great. No, thanks, Sharendra, and thanks for the opening remarks, especially when you say that, okay, we will not overload the audience with lots of products and solutions, but we would like to share our experience and case studies. And I would rather hear your feedback and questions and try to make it an engaging learning session. So please feel free to type your questions during the webinar as well in the chat, and we would take as many possible towards the end of the session. Yeah. So just let me set the expectation as well. What I will be covering. I will start by talking about digitalization itself, technologies, business outcomes, and then I will go more specifics into metals industry and what are the opportunities presented by the industry to be solved via digitalization. A short overview on ABB digital portfolio, but then most of the session will be centered around the case studies that we have prepared. I will share on APC first, then our guest speaker Gaurav, he will speak about his experiences, and then I will follow it up with some more case studies from ABB. Yeah, we would like to keep it short and concise, but yeah, will be good to hear your feedback in the end. So with that, let me move to the next slide, and let's start our session by setting some context about digitalization and its associated technologies, and how do they drive efficiency, innovation, cost efficiency, etc. in the manufacturing sector, let alone the metal sector only. So if I break down the digitalization into its technologies, or how I call them, the building blocks that you see on the left of your screen. Uh, it's a bunch of cool technology tools, let me say like this, like IoT, AI, cloud computing, and data analytics, and how they are teaming up to revolutionize how metals or other material are manufactured. All right. So with IoT sensors, for example, we can take real-time data straight from the machines. Then there is AI, crunching all the data to find patterns or making suggestions to optimize processes. And don't forget about the cloud, because that gives us a space to store all of that information, collaborate with our teams, and scale up as needed. But let's talk about something more important here. The danger of getting caught up in the shiny world of technology like AI and losing the sight of the bigger picture, the business outcomes here. So I've seen in my experience engaging with some of the customers, they specifically ask whether we can use AI or machine learning to solve this, rather than describing the business problem itself. So sure, AI is cool and can do some pretty mind-blowing stuff. But here's the thing: if we are not finding a problem to fix with AI, but the other way around, right? So typically, how we go about is we analyze the problem and then get the best tool to fix it. And you will see that example time and again in the case studies that we will show you. So if it's not delivering value for your business, then what's the point, right? So for me, that's why I've written it at the bottom. Digitalization is just an enabler. Yeah, it's a journey, but not the destination. So it's an enabler to drive results like sustainability, efficiency, cost competitiveness, and in general to make our businesses and people better and safer. Yeah? So yeah, in my experience, generally we lose sight. So let's keep our eyes on the price, the business outcomes on the right side that you see. And with that note, let's look at the next problem about how, right? So in the last slide, we described what to do with digitalization as a tool, right? The business outcomes that were shown there, coming specifically for your organization, what your management have, the prioritized business objectives, and how digital can solve it, right? So this slide will talk about how to achieve those goals, or how to achieve the digital transformation in general. So here is an attempt to show at a high level what can be the different milestones or how I call them the maturity levels as you see them, 2, 3, 4, and 5, in an organization's journey towards fully matured digital organization. So a few years back, if I have to talk about most of the metals industry, I would see at the step two, maturity level two, locally automated. We have automations, all fully automated rolling mills, melt shops, and all the individual processes. But typically, those are silos of automation. But now, already few years you know back or front, now we are fast becoming more connected. So already transitioning towards three, and of course, I see a lot of applications of optimizations and AI, etc. as well. Yeah, so there's a big shift happening. Things are changing pretty fast. But in no way I'm saying that first we have to achieve a connected plant and then only you can invest in optimization. So that's not possible, right? To invest only in infrastructure first without getting value out of it. So you connect parts of the plant required to achieve a particular project interest, and like that, many parallel initiatives can run. This is more practical way of running any digital transformation initiative, right? But still, this slides gives you a framework to think on how to move or plan in general, right? When we think about that, I think data is becomes the key, and data plays a central role, as we all know, in Industry 4.0 or digitalization journey that you see at the bottom. Yeah, you see at the bottom how I've kept that how data is used more and more when customers move from one maturity level to another. Yeah. So, for example, a fully automated plant would use data for control in automation layer, but then as you move along you would capture, store it, contextualize the data. What is the you know what is the trustworthiness of the data, what is the quality of data, and in the end what role data plays in decision making in a fully mature organization. I heard a catchy phrase about this and I would like to repeat here, like while industry 3.0 was about automating processes, 4.0 is about automating decision making using data from different silos, be it operations, maintenance, by having sales forecast, supply chain, all together. So having data, the right use of data to have data-driven decision making to improve the efficiencies and other objectives that we talk about. So after the data is connected, after typically step three, what we have seen that there were a lot of initiatives from customers towards that, and of course that itself can bring tremendous value. But before jumping to step five, I mean, we typically miss the step four, which is being collaborative. So how different departments or processes can work collaboratively if information is shared across transparently. For example, from upstream about production forecast, material tracking, like about your like torpedo availability, forecasting arrival times to your melt shop, for example. It will help effectively plan the downstream processes, right? So having information, just having right information at the fingertips is also like a superpower, right? And our guest speaker and also myself will show a case study which benefited the end users on this. Yeah. So yeah, a little context on how digital is achieved in my experience in some of the organizations. Then I moved to a deep dive into metals industry specific. Yeah. So metals industry has certain aspects which are very different from say chemical or other process industries. So I would like to highlight those and how you have to use different digital techniques to address this. So firstly, let's talk about energy efficiency, which is, as Shailendra also mentioned, a big concern, or I would put it a big opportunity in metals industry to improve. Unlike continuous processes, metals industry often relies on manual batch processes, right? Especially upstream iron and steel making shops, and that can lead to energy peaks. So energy demand forecasting is very crucial use case for optimization. And additionally, for an integrated steel plant, if you have byproduct gases produced, which are used as fuel gases in reheat furnaces or captive power plants, it presents a very complex yet vital opportunity for energy optimization, right? And it's very peculiar for metals. Then maybe move to another, uh, material tracking. Again, a task very peculiar to metals industry as material moves in torpedoes, ladles from one process to another. So efficient tracking becomes imperative. for streamlining the operations and operations planning. So, unlike other industries, material, moves, a lot of manual operations are involved. Yeah. Then quality control, another aspect, another critical aspect, I would say. Detecting defects in the produced coil or ensuring the desired quality of intermediate, like pellets, sinter, requires advanced solutions, often leveraging computer vision technologies. So I see computer vision, image analysis, or even video analytics in some cases has a lot of potential, to be tapped still. Finally, the overarching goal of process optimization with the constant movement of equipment, material, cranes presents yet another opportunity for digitalization. So whether it's scheduling operations or maximizing throughput, digital technologies offer promising solutions to optimize every aspect of manufacturing. So these are some of the opportunities that I have seen, at least in my experience, working for our customers. Good. Then coming and drilling down to then what ABB has to offer. So ABB, as you know, we work more closer to manufacturing. So more manufacturing part of the digital, more operations and maintenance related. So we divide our portfolio into 5 pillars. You see at the top, asset performance centered around the asset itself, the performance, the downtime of the assets, how we can uh, avoid it or reduce it. Process performance and operations, quite similar, but process performance is more related to like advanced process control, so kind of level 2. As we say, on the automation layer, can we improve with the use of data and models. Operations excellence on the other hand is more sits in traditional mindset of level 3, where MES, scheduling, optimization algorithms sit, which is operations excellence. Sustainability, I think no doubt there, it one important opportunity to improve, and we have some solutions for that as well. And last but not the least, connected workforce. It's an emerging portfolio for us as well. And here, instead of process, the workforce or the operator is in the focus. And typically, for such portfolio includes either the safety aspects of the people or reducing the workload of the people, like by digitizing the logbooks, digitizing the maintenance workarounds, and so on. So we have these 5 pillars, and we have a platform which we use agnostically to other industries as well. So it's industry agnostic platforms, most of them. For example, in asset performance, there's a lot of assets like motors, drives, pumps, those are common, right? But on top of that, we have very specific metals applications that you see at the bottom, right from the stockyard to iron making, steel making, and also downstream rolling mills. So that's how we position our portfolio. We have uh, industry agnostic portfolio platform on which metal specific applications are onboarded. Good. So that was a short from me about the opportunities presented by digital, and but digital is a large aspect, so everyone uses its own lens to visualize. So it will be good for us if you take this poll and share your views. What are the opportunities you see in your day-to-day work for your organization or for the plant you work? And it would be good to see whether it resonates with the ones which I have presented or not. So please go to slido.com, or you can use your phone camera to scan the QR code and then put your input there. So Shalaka, if you can present the slide of results, then we can see what people are typing in. Yeah, I would encourage all of you to type. Let's make it engaging. Let's see. Let's learn from each other. So let's take a minute. Yeah. So I see hot metal ladle tracking. Okay. Very important. I think I'm coming across this requirement quite often nowadays. Yes, thank you for that. I still see people typing, so let's wait. Furnace optimization. Okay, I assume it's about reheat furnaces, which are also kind of energy usage. Okay. Then we have about automatic triggers for condition-based monitoring from critical equipment. Yeah, definitely. I think this is one of the most popular field. Yes, sure. Asset reliability. Yeah, using sensorization. Hot metal temperature. Yes, I think you nailed it. I think ladle tracking and other projects, I think in the melt shop or especially in the upstream, I think the temperature is the key, right? Temperature and chemistry at each process. So yeah, I mean, if we can either monitor it directly or estimate it or yeah, help the operations. Good. So yeah, I think nice comments. Maybe just few more seconds, Shalaka, then we can shift back. Okay. If we can. Okay, good. But yeah, thanks for participating. I think it gives a view about what are the opportunities that you see. Good. Then let me move to the next slide. So I will present one case study on advanced process control. Advanced process control. Some of you coming from automation or control background might realize APC or even model predictive control is the term used. It's one of the proven and established technology to optimize complex processes, especially for continuous processes. So that's why we see only a few use cases in metals industry. But this is a very, I would say, mature technology in say oil and gas or cement and pulp and paper, right? But it works by modeling the process behavior, predicting the process behavior, and using that models to provide closed loop set point changes to the automation layer, right? So that's how it works. I think that's very important to note. Unlike many other digital solutions you will see, this is one of the technology that works in closed loop for improving the efficiency and quality. So as I already said, yeah, it's a standard approach. So that's what make it scalable. So ABB has a standard platform, and you can fit any process on that. So we have done that even for different industries, and even in metals. I would show you a lot of processes we have covered using the same platform, same framework. So it is that powerful technique in control theory. Yeah. So it works on top of PID or automation layer, and the output of this is set point changes to PIDs. And as I already mentioned, it works in closed loop control. I'm again highlighting, and that's why the benefits are tangible. Because it does not rely on human intervention to upload or download the results to make the potential realize. So in simple terms, if we have to see, it sits on top of automation. So it has a data model at heart. So it's fair to say it has a mind of its own. It knows the process dynamics, so that is modeled and kept at this layer. So you can call it a digital twin as well for control. And we have to configure whether we want to run it for maximizing the throughput or minimum energy. That we can do. That's actually also very key. And we can also define the constraints on your key operating variables so they don't go out of bounds. So it can run in closed loop without the fear of the process going unstable. So it's that it's that proven technology. So it's not so common in metals industry, but you see some of the use cases we have mentioned on the left, and many of them we have already delivered. And you will see some examples from me and also from our guest speaker as well. Let me show an example from a pellet plant, because you see a lot of opportunity there, and not just pellet, in a center plant as well. So this is a typical pellet plant, and when we started, we a few years back, we start with this, analyzing what are typical problems and then potentially can be addressed by APC. So we look for typical process variabilities, like you see, like there's ore grinding at the top in the beginning. So we have to control the variability in grinding quality. Then there is a balling disc to make the green pellets. So we have to handle or remove or reduce the green pellet size variability. So reduce the rejects and also increase the throughput. Then if you come to pelletizing machine or indurating machine, it's about temperature variations, which results in pellet quality variations and also limits how much you can increase the throughput. So starting from grinding to indurating, we have deployed at all, and many of them at JSW itself, which they will present. Uh, so I will not spend much time here, but I will just take you through a couple of use cases, how it is typically used or how it is typically developed. So this is a grinding mill example, like a ball mill. So typically you have to see for measured signals and divide them into control variables that we want to control, that you see here in the dark blue. Or maybe we want to maximize. If you maximize throughput, then we have to find a measured signal that signifies that, that flow rate or the speed, which signifies the throughput, and then we can put it into the maximization zone of the APC. Then there are manipulated variables, meaning the variables whose set points can be changed to control. And let me make a point here. When it changes the set points, it doesn't make sudden changes. It always make incremental changes to always be in control, right? And then there can be other parameters like quality. There can be measured disturbances that we cannot control, but we can use them as feed forward, predictive variables. Once we identify it, so it in the framework of APC, we collect the data, make the model, and then in real time it predicts and optimizes and comes up with the right set points. So that's how it works. So this is for the grinding mill, and similar fashion. Next one is very fascinating, very interesting example. That is for the balling disc, which feeds the green pellets to indurating machine. And generally pellet size measurements is not continuous. There is no sensor there. And if there are undersized or oversized pellets, they are either rejected or recycled. And that is not good, because then the same material goes over, you increase your specific energy consumption, and it can also becomes the bottleneck for increasing the throughput. So here the controlled variable is pellet size, and manipulated variable is disk speed. Yeah, there can be more, like the tilt angle, etc., water addition, but that depends on your control philosophy or whether you have them as measured and controllable or not. But in this case, we have one problem: we do not have the pellet size measurement, right? Remember, I said it has to be, everything has to be a measured signal. So if we don't have the pellet size measured, we resorted to computer vision image analysis to detect the pellet size. So if you have multiple balling discs, we have one camera for each disk, uh, who is measuring the pellet size continuously in real time. It gives that output, the size distribution goes as an output to APC, which then changes the set point of, say, balling disk speed typically. So it typically results in a lot of reduction in the reject. Uh, and if the downstream process, the indurating machine allows, you can also increase throughput. And also it reduces the specific power consumption, because you're not recycling again and again the same more material to produce the same throughput, right? So this is very interesting project, which we have done quite recently. Then with another project on indurating furnace as well, with the same concept there. It is but here the control variable will be the temperature profile, the burn through temperature, because that is very important to keep the temperature profile pellets are exposed to, so that the quality is in check. Like CCS, tumbling index. It can also be used to reduce the ID fan you see at the bottom. The fan power consumption you can optimize with this. So similar philosophy, we use manipulated variables as uh, the fuel flow through the burners in different zones of the indurating machine, and then the results we have seen are very promising. And first it tries reducing the variation of the temperature profile and ensure that the burn through temperature is is achieved, that itself will help the pellets to reach at the right temperature, which improves its quality. So these are some of the examples, multiple examples. We have also in ore dryer, for example, we have implemented APC. So I would say this is one of the very promising technologies, and with the advent of this mathematical modeling, we can use this advanced process control more and more in metals, and not just in pellet plant. Can be in sinter plants, can be in your boilers if you have captive power plant, and so on. Good. So much from me, and I would like to hand over now to our guest speaker, Gaurav Patil, who is a member of Digital Excellence team in JSW Steel Limited, Dolvi. So, Gaurav, it will be interesting to hear from you and the experiences from JSW you want to share with the audience today. So, yeah, stage is yours, Gaurav, and I'll handle the slides. You let me know when to change.
Thank you, Tarun. As mentioned earlier, currently I am working as an assistant manager in digital transformation department in JSW Steel Limited, Dolvi. JSW Steel is a flagship business of JSW Group. JSW Group has a valuation of over 23 billion, including its US business also. JSW Group is also interest in the energy, sports, infrastructure, as well as cement, and also into venture capital. So, as a part of JSW Steel digital transformation team, I am going to present today how JSW Dolby has incepted the digital transformation and how it is currently going on. So, this is a process flow of JSW Steel Limited Dolby. So, in JSW Dolby, we are getting our raw material from the sea via sea route, road route, as well as rail route. This raw material will be handled by the RMHS team, and then RMHS will supply this raw material as per requirement of its customers. These customers are pellet plant, sinter plant, and coke. Pellet plant produces pellet, sinter plant produces sinter, and coke converts coal to coke. This pellet and sinter will fed to the blast furnace, and blast furnace will convert into the hot metal. This hot metal will be supplied to the Konak shell. As well, DRI plant will get the pellet from the pellet plant, and this pellet will be converted into DRI. In Dolvi, we have a Konak shell for the hot metal conversion to the liquid steel. So in Konak shell, we do first blowing and then arcing, which is like combination of converter as well as arcing furnace. This liquid steel generated from the Konak shell will be fed to the casters, and this will be rolled into hot roll coil and TMT bars. Next slide, please. Yes. In Dolvi, we have incepted the digital transformation in 2017 and 18. The background behind this, that initially there is a lot of manual intervention in the processes, and there is a lot of scope for the improvement in process, as well as there is a lot of scope for the cost saving. In 2017, we have started with we have initiated this digital transformation journey with the help of experts, and after that we are continuously introducing new technologies in Dolvi, in JSW, and continuously horizontally deploying it across the group. So main part, major role in the digital transformation success of the JSW is that employee engagement in digital transformation. To ensure the high employee engagement, we are continuously conducting the ideation workshop, then participation in the various competitions, then conducting different training programs, and sharing know-how sessions and interplant discussions with the Vijayanagar team, Salem team, as well as we are conducting like quest, and there is a platform for the all employees where they can learn themselves. There is a self-learning platform like digital central platform. Next slide. Hello. Yeah. In JSW, we focused on the various technology domains, and there are the artificial intelligence, GPS, IoT, big data analytics, simulation, machine learning, then process automation, and cloud computing. And we have implemented different initiatives by considering different technologies, and these are the really helpful in our digital transformation journey. So I am going to present few shining cases today, which we have implemented in the JSW. So first case is Uh, Next slide. Thank you. First case, which Tarun has already mentioned, that APC for the volunteers. The problem statement for this initiative was initially there was a high rejection rate in the pellet field. In pellet plant, there is a balling disk which generates the ball size pellets, which will be fed to the induration furnace. Before feeding it to the induration furnace, there is a screening for the pellets between 8 mm to 16 mm, and we were getting the high rejection rate in the screening. So we have implemented with the help of ABB this initiative in the JSW Dolby Pellet Plant 1, where we have a baseline of 19 percentage, that initially we were getting the high rejection rate of 19 percentage, and we have taken the target for the rejection to reduce to the 10%. So this is the typical architecture for this APC, that we have installed the cameras for the each volunteers, and this video feed will be fed to the Cerebra server. Then server will give the real time size distribution of the pellets, and this real time size distribution, according to this real time size distribution data, we are controlling the speed of volunteers. So next slide, please, Tarun. Yes, this is solution architecture which I have mentioned earlier, that we have installed the cameras, and this camera feed will be fed to the server, and this is controlling via VFD. So volunteer speed will be controlled by VFD. Also, we are controlling moisture also, so that we are getting the desired size distribution of the pellets. So results of this initiative was really incredible, that we have reduced the rejection rate from 19 to 6%, which is even lower than the target we have considered initially. So due to reduction in the rejection rate, we have seen the increment in the production rate also. So this is the initiative we have implemented with the help of ABB in pellet plant 1. So next shining case, next slide, please. Thank you. Next shining case we have implemented in SMS1. Uh, the problem statement behind this initiative is that in Konak Shell there is a lot of manual decision making for the operations, and there were no proper planning. There were no proper planning for the production, and there were no proper planning for hot metal mixing, due to the less visibility of torpedo, and due to the less visibility about the tap out, and there were no accounting for the delays and breakdown. So we have implemented this initiative so that we will get the optimized plan for the next 2 hours. We can get the visibility of the torpedo, that when how much hot metal is on wheel, how much hot metal is in the blast furnace, and how much hot metal will be available for the next 2 hours. So we can optimize the 4 Konak shells, and we can optimize the production by using this production plan. Due to this, we got the synchronized upstream and downstream production. So it has been resulted into increase in liquid metal production. So for this initiative, we are using a geofencing to track the torpedo, and data analytics, and as well as linear programming to get the data from the different sources, and optimize this, and get the optimized result for the next 2 hours. What will be the best plan for the next 2 hours, so that we can get the optimized use of this Konak shell. And we have also provided the persona based dashboards for the HODs, as well as operator, as well as blast furnace operator. So this is the basic overview of this initiative. So next slide, please. Yeah. For this initiative, we are getting the live hit data from the level 2 system of SMS, as well as blast furnace production rate and DRI production rate. We are getting it from PPMS system. We have implemented a separate system for the torpedo tracking system, which is a Suichi server, and we are getting the payment of the torpedo from the Pi server. So this data will fed to the nonlinear optimizer, and it gives us the next 2 hours plan for the production, next 2 hours plan for the each Konak shell, and we are getting the, like, what would be the possible consumption of the utility for the next 2 hours. It has a huge impact in the production, improvement in the production in the SMS1. So it is really optimized. It is really giving an optimized production plan, and it has resulted into the liquid metal maximize the liquid metal production. So next slide. Okay. Uh, Next shining case is like setup time reduction by using vision system in SMS1. Initially, there were no visibility for the micro level activities during the setup time, and there will be no decision making according as there is no data available where we are losing our where we are losing our data and where is the scope of improvement. So we have installed the cameras to track the all activities, all micro activities, and which will uh, camera and which will analyze the each activity, and we are getting the log for each activity, that this activity is consuming this much time, this activity is consuming that much time. So we have created a system in that we can get the log for the delays for each activity. So in case there is like continuously we are getting the delay for the specific activity, then it will be escalated to the HODs, and then HODs will conduct the brainstorming sessions and discussions with the operators why this delay is occurring continuously and all those things. And due to this, we are able to reduce the setup time. Initially, we have taken the target of 12 minutes from the baseline 14.6 minutes, and currently we are getting it around 11.4 minutes setup time reduction. So next slide, please. In this initiative, these micro level activities during the setup time. Uh, we are tracking here that top lance positioning, then hot metal pouring, end brick cleaning, launder insertion, furnace leveling, hot metal positioning. These are the micro level activities we are tracking by using a CVML system, and it has resulted into reduction into the setup time to 11.4, and total overall cycle time has been reduced from 70 minutes to 67 minutes. So it has resulted into the improvement in the production in SMS1 also. Next slide, please. Yeah. Next shining case, that is Sampak. Sampak is a digital logistics management for road transport. Initially, there was lot of manual intervention in the logistics, outbound, inbound, and in-plant logistics process. That due to this, there is a queue inside the plant of trucks. Inside the plant, and there is a queue of drivers standing in the queue for the paperwork, and there will be a lot of scope for the error due to this manual operation initially. So we have implemented this digital logistics solution in Dolvi as well as in Vijayanagar. So it has the RFID. We have provided the RFID on each truck, each outbound, in-plant, and inbound truck, and and it tracks the movement of the truck across the plant. It also tracks the movement of the driver, where we are actually getting the delay and all those delays, and we are counting for each delay. And as well, we have reduced a paperwork in the logistics operation. So this solution, as a technology behind, is that we got the SaaS based solution for the all logistics operation, and we are milestone get updated by using the level 1 system, which is like RFID system, and tracking using the RFID system. And also in this initiative, we have implemented here is manless weighbridge. There is most of the delay were from the weighbridge weighment operation in the logistics. So we have also convert our manual operation in the weighbridge to the manless operation. So due to this initiative, we are getting the end-to-end visibility of logistics operation. Next slide, please. In this initiative, we are tracking all inbound trucks, interplant movement of trucks, as well as outbound trucks. In outbound, currently we are live with the outbound operation in Sampak, and we are tracking coils, pig iron, and pellets, as well as billets and TMT bar outbound operation. This project was divided into 4 modules. First one is a parking yard management system. Whenever truck arrives in the JSW premises, then tracking starts from the parking yard. Then we get the pre-intimation of the truck arrival in the parking yard, so that our planner, which is not a manual operation now, which is now automatic operation, that DO will be assigned to this truck to carry the coil, and then truck will be entered into the plant, and then all operation will be tracked by using this digital solution. So what benefit we have achieved from this initiative is that high reduction in the TAT, which were high reduction in the TAT, and there is no scope for the error now. So this is the initiative in the logistics digitalization we have implemented. Next slide. In JSW, we prioritize safety, and there are a lot of digital initiatives we have implemented to improve the safety in the plant. As Tarun has already mentioned, that connected workforce solution. So we are also in the POC stage of connected workforce solution in Dolby. Then there is a laser scanner for ELF ladder. Then PPE violation detection system, which is CVML based system, and flare stack thermal imaging system. These are the systems we have implemented to improve the safety of workforce and safety at workplace. So thank you, Tarun. Over to you.
Thank you, Gaurav. I think very interesting, and I'm sure it will motivate others also, because what I've seen in the past working with JSW, you have a very thriving ecosystem of innovation with suppliers like ABB and others. And some of the solutions are very unique, I must say, which uses different building blocks that I was explaining in the beginning, like some IoT sensors you have used analytics, you have used optimization techniques. And always it is good to see that you had some business target in mind when you started the initiatives, whether it's reduction of setup time or the reduction of rejects that we did together. So I think, yeah, very good examples, shining examples of how digital technologies are utilized to achieve business outcomes. So thanks for sharing with us, Gaurav. Thank you very much. So I will continue from here. I will give few more use cases for our audience here. Uh, Let me move to another project that ABB did for improving the efficiency of melt shops, steel making shops. So in this slide, I've just mentioned the typical challenges you would recognize. There's a lot of because shops are characterized by a lot of movements. You would see a lot of material movement in ladles, crane movement, lot of manual operations, and so on. So tracking of material along with the ladles is important to improve the overall efficiency of the steel making shop. Because what is essential here is to have the right temperatures and chemistry at the end of each process. So melt shop can produce right quality of steel with highest production rate, right? So that's typically at a high level the objective. So a project is not targeted at one process like EAF or LF or caster, but to optimize the overall material movement along with the temperature optimization. Yeah. So in the next slide, I have tried to show the challenges that you saw in the last slide on the left, due to lack of real-time visibility, due to, insufficient or no thermal history, a thermal loss prediction becomes, very challenging. And why that is important? Because there is a very important KPI measured by operations team in a melt shop is superheat compliance. That is at the center here, and which simply means how many percentage of heats reach the caster at the right average superheat temperature, which is like for any grade of steel, it's liquidus temperature plus say 17 degrees or 20 degrees in that range, at which the caster can produce at the highest productivity. Because higher temperatures, one has to slow down the caster, and of course, low temperatures might also get the high chances of rejection of the entire heat or batch of that material. So avoiding caster slowdowns and impact on melt shop productivity is one of the objective here. And it also impacts the energy input in the LF, because if earlier operators are overheating, then it reduces. Typically, we have seen 5 degrees per heat as well, and also the quality of steel because it is at the right temperature. Yeah. So what was our approach? I mean, we just don't have the thermal model. We have three different modules here. First is the ladle tracking. I think someone already in the chat box was asking about it. So ladle tracking is very important. To have the complete ladle thermal history, and this is a very hardware driven solution. So we use we don't use RFID here. Of course we can use that, but it poses some challenges due to the high temperatures. So we use radar for crane positioning. We use some other sensors, but the idea is to go beyond tracking and develop the applications on top of it. Right. So after you get the tracking in place using any of these technologies, the other two are the software applications that you see here on the crane operations management, which is typically done if you see that there are delays due to the crane availability, like tapping ladle delays and so on. So that is one. But most important one which we see can give benefits is the thermal model, and this is a machine learning model to ensure the superheat compliance, which I already explained is a percentage of heats reaching at the right temperature. And the output of the model is the lift temperature to the LF operators, so that it reaches at the right temperature at the caster. So that's the objective of the thermal model. So that's the third module. And of course, there are other modules where, because since we are tracking each and every movement of the ladles, you can have time motion analysis. You can see where the bottlenecks are. You can do refractory management and so on. So it's a complete package, and that's what we call smart melt shop. But this is also very modular. And what we have seen that most of your shops have the data there to have only the thermal prediction model as well. But of course, it depends if you have the data in your level 2 or some other system to feed to the machine learning model. Yeah. So I'll show some screens how the output of the tracking module looks like. So you have a real-time view of your melt shop in your control room. As you see here on the screen, you have these yellow blocks which represent the crane. They move, and you see that this crane is carrying ladle number 3, and you can click on any ladle and you can get information about that ladle or heat. So it is like having information on fingertips, real-time information, and you can see it visually. And even without additional modules, I think it helps in coordinating and locating the right ladles and make the job of, say, ladleman and shift in charge, more efficient. Yeah, and then move the ladles as per the tapping needs or as per the caster needs. Yeah, and the live tracking screens, of course, are adapted to the layout of wherever we are deploying it, and they are designed on it is by scale. So whatever you see is as per the scale of the real shop that you have. But then, as I already mentioned, the real value of is generated from superheat compliance or thermal model, which is the most important module, which I recommend my customers to go at least for the first step. So it considers ladle thermal history and the forecasted events uh, based on the based on the caster remaining time, based on the tapping event. We also forecast the events. So all this taken into account in the machine learning, and it generates the output for the LF operator, that what should be the lift temperature of the ladle. So typically melt shops would operate with say 60-70% superheat compliance. Uh, and with this model, we can go up to 90%. Of course, that depends on the quality of data, but yes, I think that is possible. Yeah. So these are typical results that can be achieved, and in some of our deployments, we have achieved with the superheat model. The most important one is highest impact is on avoiding caster slowdown, which can improve productivity by even 4-5%. A huge boost to productivity, which is the largest contributor of this benefit that you see in the profit. Uh, if you have crane management system, you can also have reduction in tapping ladle delays. And what we have seen, as I was saying, around 5 degrees less arcing in LF in case the operators were overheating it a little bit. So it has an impact on power consumption as well in LF. And of course, as I said, it reduces the workload of middlemen, shift in charge. So it reduces the footfalls and make the shop more efficient and safe to operate. So that was about melt shop. So I started with the APC, which is more upstream, then steel making shop. Then let me finish off with some use cases on the rolling mills, downstream rolling mills. And there we have a good package of data analytics use cases. We have done a lot of projects with our data analytics package. They analyze tons of data. Some are high speed millisecond data to fine tune mill operations and make the product better. But at the core of analytics is the data, right? And we have the platform, because that is first. You have to have the platform that can integrate the data from different systems, because that's what the entire idea of digital or industry 4.0, to take the data from different systems and have and enable data driven decision making. So be it DCS systems or historians or even say other systems using any databases, we use open communication protocols. We can integrate with all these kind of systems, be it fast data loggers like EBA or even ERP or MES systems. We can, which can give typically material grade or the thickness which is getting produced or not. So true value is generated from 360-degree view of data. Hence, it is important to bind all this data about material, about equipment, to get meaningful outcomes from any data analytics project. So I think this is the key here. So we have the framework which we apply across, which will enable us to collect data from different systems. Next step after acquiring data is to unlock value from the data, bringing together data, domain, and technology. Here I have put domain because you need to have some understanding, because if you talk about a coil, you might have to look or convert the data to the length-based data to compare it, say, from one pass to another in a cold rolling mill, right? So given ABB's experience in implementing even automation projects in this area and having the domain know-how, we have made specific analytics suites for different processes. So we have some pre-built analysis like comparing lengthwise data of a coil, finding out thickness deviations, correlating it with process parameters, and so on and so forth for diagnosis. So I think that's what we bring with our know-how. So let me highlight some of the use cases that we hear from our customers. You see on the screen now. So process optimization is one big topic. By optimizing the rolling parameters, so mill can run at highest efficiency or speed. And at the same time, we see the need to track the production cost associated with the finished product. Some of the manufacturers term it as digital coil, which has all the information embedded with it. And if you have a code, you can get all the information about the coil, right? And about the quality, about the other consumptions like energy, utility, and in the end, you can have the cost per ton. But most importantly, all these analytics should allow us to see performance trends over a period of time, say months altogether. So to diagnose if there is any deterioration, consistent deterioration, and if that can be diagnosed or treated. And typically, when you look at the rolling mills, you have very fast, high-speed data, and it is difficult to derive long-term trend, right? So you have to compare, of course, the same product, same campaign when you ran last time. What was the performance? So it is difficult to derive with starting with millisecond kind of data, right? So that's why we embed that in an analytics package, which converts that data into this meaningful performance scores that we do. So this is one of the case studies where we analyzed for a 20 high cold rolling mill for a few days of data, and it already gave some interesting findings about, say, long coil preparation times, inconsistent reversing times. It can automatically tell you between the passes. Now, there might be reasons for this, and that is the next step of diagnosis by correlating it with input material or other equipment issues. So for this data, we found there were correlations between thinner material and poorer thickness quality, an important observation, and the system recommends to tune the AGC, the control, for treating this. And like this, we can feed days or even months of data to the tool and come up with recommendations. So we can also run it in real time. So you can see the real time moving performance, continuous performance of the mill with this. Similar package is available for processing lines as well. I'm not going in too much detail, but yeah, what it can essentially do is it can benchmark the performance with months of data that you feed, and then it gives a score for the currently rolled coils. And then we can use analytics to have correlations and what is different from the golden period of a golden coil to the current rolled coil. So that is the basic premise on which analytics is run, comparing performance over time windows. The next use case is a pretty interesting one for a wire rod mill with a specific problem statement. It is for anomaly detection in the torque profiles of rolling stems. And you can see here some abnormal signatures as you see in the picture. can result in the turned over bars and result in the volatility or the shape issues. And if someone is continuously looking at the high speed data, then of course you can find it manually. But if you have to automate it and inform it as soon as it is detected, so it can be treated. But it's difficult to have someone looking at it continuously, so easily can be missed. But it is easier said than done, because if you have to do it automatically, then there are a lot of fluctuations in torque profile. Not all of them are associated with this problem. They can be because of the temperature, speed corrections coming from automation, and so on. So we have to train this machine learning algorithm to look for the specific signature and avoid the others. Otherwise, it will result in loss of a lot of false alarm, which is actually one of the very common problems or challenges that we encounter in data analysis. Yeah, I mean, there are algorithms which work, but if we give false alarms, then people stop using. So I think we have to be very aware of that. Good. So with that, I conclude my presentation. I hope that some of the use cases I have shared resonates with your challenges or better opportunities in your mills or plants. And it will be great if you can share which of the case studies presented today suits your requirements the best. And for that, again, if you want to go, please go to slido.com or just use your camera to scan this. And let's see what we have responses. So Shalaka, maybe you can show the Slido to the audience. Next. Thank you. Yeah, there were quite many. So yeah, I hope you remember some of them. So let's take a minute here to record our responses. Okay. Yeah. Also, you can type in your questions, because immediately after this, we will go for Q&A. So if you have questions, please type in. Okay. I see, Gaurav, what you presented, dynamics optimization model is also of interest. Data tracking, yes, definitely. Okay. Good. So, Shalaka, then we can move to the Q&A. Thank you for your responses. Give me a moment. So, first of all, thank you all for attending, and I hope you have some takeaway from our session. And please contact us even later with my email ID. And I hope I get flooded with emails and with the interest. But now also we have a chance to interact with Q&A. So you can type in questions now, or you can contact me later on this email ID as well. So let me go to the chat and try to pick up some questions. Okay. There are a lot of questions about sharing the materials. So I guess, Shalaka, we will share something, if not the entire recording, at least some summary, right? So yeah, we will try to. Yeah, there is one question about cloud computing or edge computing. So instead of cloud computing, if one wants edge computing, is it possible to, honestly speaking, in my experience, most of these initiatives start on the edge only, right? I mean, of course, if you have cloud computing, even better. We can use better AI and machine learning services available on Azure or AWS. But I think all the solutions which I presented today are done on the edge, on the local servers. right? And I am sure what Gaurav presented is also on the edge. So the short answer is yes. Not everything I presented or not everything we do is on the cloud. Yes, there is a potential to do it on the cloud, but there is no restriction to do it on the edge. Especially APC, for example, it has to work in closed loop, so it has to be on the edge. Okay, let me pick up another one. There is a question on in metallurgical aspects, how accurate is the data coming out of AI or any automated tool is worth for using in process parameters? What are the pros and cons of this? I think excellent question. I generally covered this in some of the other talks that what we should do, because unlike what we see in our day-to-day life, what in B2C kind of a setting where we have a lot of consumer data. Here, the data, first of all, if somebody has started recording it, it is limited. It does not cover enough, grades or materials. So whatever conclusions we draw, we have to be careful, or we have to ensure the right data quality, sufficient data quality. And typically, what we do to address this challenge, the typical solution, what we do is we have some checks coming from the domain know-how. Even from say that thermal model I presented, we have machine learning model, but we have some rules based on the operations know-how, that when there is a turnaround time of ladle is so much, when the liquidus is that much, typically it should be in that range. So there you have to put some checks and bounds on this AI algorithms, mainly because you never have the best data set. So very good question. I mean, in my opinion, we should not blindly apply AI. First of all, we have to see whether we, instead of AI, we have a very deterministic equation, to enable that. Otherwise, we have to check it with the operation know. So yeah, completely agree there. Yeah, there's another question. Can you explain modular form, like if someone wants to incorporate energy management with respect to production? Okay. I don't get it fully, but what I understand is, of course, so ABB has this energy management, and that is very modular. So first is we go for the monitoring, right? So we monitor the energy, but we also, since we have other operations management tools that I showed you today for say rolling mill, we have to also track the coil, for example, and then attach the energy or utility consumption to the coil or to the production. So you can see with grade, thickness, you can slice and dice the data with those production or other parameters to see the energy or utility consumption, right? So yes, I mean, it can be done. So that's the first step, monitoring. The second step is typically the forecasting, typically for the entire plant, because energy is generally availed from the energy department for the entire plant. So uh, we have many requests coming to have the proper energy demand forecast, so that the maximum demand can be the penalties can be avoided, so you can have better forecast of the energy. That is the second step. And the third is, of course, the optimization. If you can balance out and have a smooth power peaks, so you can smoothen out the peaks of power, so you don't go above the maximum demand. So yeah, these are some of the use cases we encountered. And typically we start modular wise, going from tracking and monitoring the energy consumption per ton or per coil, even to that level. Yeah, we got, I think, couple of comments about ladle tracking. We are searching for hot metal ladle tracking. So yeah, okay, yeah, we will contact. Thank you. How ABB can help in predictive analytics of electrical systems, so to increase reliability of the system? Yeah, okay. So yeah, of course, ABB being the supplier of electrical components, we have starting from a lot of IoT sensors coming from say our motors, drives, even say switchgear. We have sensors also there to monitor the condition. And for some specific faults, we typically take the data from you and try to have more prediction analysis. But ABB has a library of electrical assets for monitoring their condition and for monitoring when they would need a maintenance. So yes, that is. Gaurav, do you see any questions which can pertinent to you? Probably, I think the dynamic process optimization that you showed. I think I see some comments there. Yeah, yeah. Maybe,
And
maybe I can ask a question around that. You know, so
yeah,
you are
yeah,
using non.
there is
Give me
one question for tracking of billet and slab link in caster.
yeah.
So we have implemented the solution for this problem. So we have implemented by using a video analytic based solution for the tracking the billet length measurement. So we can get the data of the length by the video analytics system. So
Mhm.
there is a question from Sandeepan Chowdhury. So this we can they can also implement in their plant.
Okay. Yeah.
Yeah.
Thanks. Thanks, Gaurav. Um, there is a question about how to extract reliable data, as sometimes even a level two automation is not used by operator due to misleading. Yeah, I mean, I can't agree more. Typically when we go with our data scientists to any problem, they would demand a large set of data, right? But that is almost never there, uh, and we realize that, and that is why this part, what we call data engineering, takes the most effort. So as I was saying before, you have to define some rules with the operations people to trust the reliability of the data, or you can check. You have to omit data, then you have to go far back in time to collect more and more data. So yes, I mean, if you have to do some machine learning models, that is the basic premise, the data. Uh, so yeah, I mean, we have to do some analysis to automatically flag outliers and other data, or even missing data in some cases. So yeah, I mean, don't have a straight answer, but yes, we generally put a lot of efforts in data engineering phase to extract the reliable data. But yeah, that is one of the challenges, definitely. There's a comment about role shop management. So yes, I think that we have in our portfolio. So there's part of our portfolio called manufacturing operations management, for we call MOM for metals platform, and for rolling mills. Yes, role shop management is a part. And yeah, I mean, you would agree that once you track the roles, and you can increase efficiency. You can of course increase the role life, as well as you can avoid uh, you know. Or you can have the better quality of the coil by having the right rolls there. So yes, I agree. Then let me see. There are a couple of questions about coke oven and blast furnace case studies. Okay, it's not here today, but yeah, I mean, I at least I don't recall any of the use cases now, but I will check and I will get back to you.
I think Tarun, one of the thing on the blast furnace where probably we are doing is the utility. I mean the blast furnace gases which are coming out.
Yeah,
So
that part is
so
yeah, that is one. Yeah, uh, but not on the process itself. But I have to check. Yeah. Okay, then the tracking of billet or slab length in caster. This is what you mentioned, Gauri. Okay. Yeah. Okay. Then I see any solution for automated coil yard management by EOT cranes, coil placed. Okay. Yeah, we have some solution, but yeah, we have to, yeah, which might look similar to what I presented in the melt shop area, where we are tracking the cranes and all. I know that I think our teams responsible for cranes, they have delivered something. So, but I don't know the details. Sorry, so we can get back to you. We have your name and address. So yeah, okay. I got your response regarding the usage of automated tool, but I have tried to make a tool using only data for chemistry analysis, but I am unable to cope up how to reach the requisite output. What could be done to improve the efficiency and ways to include metallurgical aspects in ML code? Yeah, okay. That's a follow-up question. Okay, I think we need to engage more. It's a very specific question, but you're right. I mean, you cannot incorporate directly in the ML code. Probably in the post-treatment of the solution, you might use it to check whether it is correct or not, or you might use it to guide the optimization algorithms if you are using the optimization. But yeah, that's more technical discussion we can take. You can contact me. on my email. So another question is, what will be the basic digitalization infrastructures required if, as is level 1 automation? So yeah, that brings to my original one of the initial slides where I said that yes, generally there are different levels of maturity starting from automation itself. So for digital, we have to have automations, at least local automations. So level 1 automations, that is generally a prerequisite, not always, but yes, because you have to have some data source, and then you have to have connectivity to other systems. So if you want to do planning, then MES system and ERP systems as well. So yes, there is some basic digitalization infrastructure required to store the data and to communicate it to any digital solution which is used, because ultimately it's about data which any digital solution will use. So we need the infrastructure around to collect and store the data. Yes. Pallet, then I saw questions about pallet and raw material handling. So yes, I think I presented today a lot of pallet digitalization cases. We will share some of these. So yeah, you will come to know. So very interesting cases, Mohammed. When is your next session? Okay, not planned yet, but yes, we will plan sometime this year itself. So I'm sure if you got this, you will get the next one as well. Thank you. Then there is a question that is smart melt shop is applicable for all kinds of casters? Okay, so the short answer is yes, of course, because as I said, it is not a solution for a caster, but more about the material movement. So what you have to ask question is the main KPI we are targeting is the superheat compliance, right? At any caster, and I think it's more important for slab casters, and then more the temperature impact maybe less in the billet. But yeah, if superheat compliance is an issue, and if because of that you have caster slowdowns or you have rejections or any other problem in the caster, then the smart melt shop is the solution to go. So that's the short answer. Good. I think I've taken up most of the questions, I suppose. Gaurav, you see any other interesting comment there?
There is one question for the coil yard management system from Manish.
Yes. Do you have any update? Do you have any feedback on that, or?
Yeah, actually, for the coil yard management system that we have currently implemented the XY mapping of the yard, and we are currently in the implementation phase for the Z map, Z axis also.
Okay.
So I think he has a question that how precise positioning of the crane would be the key to this. So we are mapping the coil by using the X and Y coordinates of the coil placed, and so EOT crane will be track the exact position of the coil and it pick from this XY coordinate and then put it on the truck. So truck also has a XY coordinate. So
Correct.
we are into next phase to implement the Z axis.
Correct. And I think this comment about precise positioning, which we encountered for cranes in Wildship area also. So there are, like this radar positioning available, which is like very accurate even to level. But the point is, it is at the point of where it is, installed, right, or erected. But the crane or the truck, what you mentioned itself, has its own volume. So it is
Yes.
very important. I have seen to have these coordinates mapped out to map the entire crane. So you're right. I mean, in terms of sensors, precise sensors are available, but also on the software side, we have to account for that because it will give you a point location, right? But none of our equipment is a point, so you have to take care of that in the solution, even when you have a precise solution. So
Yes.
yeah. No, I think let me check if you have any more. No, so I think we can conclude the session. And I would like to thank you, Gaurav, once again to share so much interesting news from JSW. And thank you for the audience who listened in and with us. And please feel free to contact us on the email ID. I'll be happy to engage with you. Thank you, everyone. Have a nice day.
Thank you.